In this video, we're going to discuss the topic of trimming. We rely on trimming to optimize our job stream calculations. With trimming, we can remove unwanted predecessors for a target job from AI's data collection and analytics. When the job stream is created, all upstream processes are included with the job. Some of these upstream processes are not relevant to the functional or scheduling context of the target job and may distort runtime calculations, resulting in loss of accuracy. We're going to explain what this means with examples, but know this. We use trimming to remove those upstream processes from our calculations to produce more accurate predictive analytics for the target job, leading to better monitoring and SLA managements. Every job stream comes with two Autotrim settings. Autotrim can force the decoupling of the target job from predecessors with mismatched execution frequencies. This means either upstream jobs with higher or lower frequencies than the target job. It's understood that these predecessors generally have no business being included in the target job's runtime analysis to begin with and should be trimmed automatically. When trimming, we remove all predecessors, but we can also include the job or not. We'll show both settings. To set trimming on an individual job, we simply select it and set a trim point. We're going to show how this is done. Trimming makes it possible to scrub the data produced by operations and the job scheduler, so that AI's analytics reflect the reality of the organization's business-critical processes more accurately. AI collects and analyzes runtimes for business-critical processes to build predictive models and support operations monitoring and SLA management. A new job stream collects runtime data for the business-critical job, and by default, all of its predecessors are included in the collection effort. This being said, some of the predecessors need to be removed from the collection process. They include technical, polling, and orchestration processes, and jobs with dependencies that run at different times or on different frequencies. They're not relevant to the organization's business processes. They distort SLA calculations, trigger false positives for overruns, and in certain cases cause visual problems in AI's interfaces. Trimming allows us to remove these problematic upstream dependencies from the collection process. Trimming can be manual with trim points or automated with the Autotrim features. Let's take an example. We have a batch process running for an application. We configure AI to collect data for the application's core update job, which the organization wants to monitor. Let's imagine it has an upstream dependency for some unrelated purpose, say a technical or polling process, with no incidents on the application. We trim this job and its potential predecessors to optimize the service provided by AI. Let's start by creating a new job stream so that we can show where the trimming functions are. We use this space to list what we want removed from the data collection process. We have two windows. In the top, we remove the predecessors of the job we selected, but not the job itself. In the bottom, we do the same, but natively include the selected job as well. Using one over the other depends on the situations we're faced with. The top window, predecessors but not the job, is useful for a number of situations that Autosys users will need to handle. Use of the bottom window is more prevalent with other schedulers like Automic. In other examples, we'll use the bottom window. We'll include the job and its predecessors. At the bottom of this window, we find Autotrim features. We'll discuss those next. Let's discuss existing job streams. Let's say we have a batch process that performs some sort of database maintenance. The business-critical sequence is this job, which updates some tables. The organization has strict SLAs on this process, and accuracy is paramount. The DB maintenance was designed with an upstream external dependency on some unrelated job scheduled at a different time. This job executes hours or sometimes days before the update job, which is the target job. This leads to visual distortions and could potentially cause calculation problems if you're working in certain schedules like Autosys. If we keep this job, then the job stream monitoring process begins when this job starts, hours or potentially days before its due time, which should be start of the batch process. The organization decides to trim this upstream job from collection so as to unclog monitoring. It's worth noting that we can trim the job and its predecessors, or trim the predecessors but retain the job itself. This is our database maintenance job stream. We have the target job, the polling job, and the dependency. We can scroll back to the much earlier point in time when the external predecessor completed. We have the option of trimming the job and its predecessors or just the predecessors without trimming the selected job. The option you select depends on the situation and type of scheduler. The top option is far more common with Autosys. Let's go ahead and exclude the job and its predecessors. We'll see the effects of the feature in the analytical components of the UI. This is the result. The upstream dependency has been trimmed, which improves the visual experience for the user. The jobstream run is around 6 minutes long as expected instead of 2 hours. The jobstream run only includes the portions of the job that are relevant. You should be aware that trim points can be removed at any time, say for comparative purposes, for example. You simply remove trimming and the first view is restored. Every job stream has 2 Autotrim options for lower and higher frequency predecessors. This is really just a continuation of what we've explained up to this point. We collect runtime data for target jobs, and sometimes these jobs have upstream dependencies on processes that aren't relevant. This is almost always true when the frequency of execution is different. It's an indication that they're not part of the same business logic, but merely made dependent as a result of some unrelated technical requirements. AI can trim these jobs automatically based on the frequency of execution. If you set the value to 2, then AI trims all predecessors that execute twice as often. This is particularly useful when job owners add these extra dependencies after the fact, leaving operations teams unaware of these changes. Predecessors are eliminated automatically, removing impacts on the collected data. These high-frequency polling jobs can also have serious impacts on AI's interfaces and the user's visual experience. We illustrated this with a process that runs every hour. It has some random dependency on a polling job that checks for a file or process every minute, presumably because the job owner wants some true-false test to return true before the job runs. This type of configuration is actually quite common. We set the value, say, to 1.5 or 2, which removes those high-frequency jobs automatically. Note that the Autotrim features are always enabled by default on new job streams. Those default values are set by the administrator in the AI configuration tool and can be disabled there as well. This means you have the option to either always or never enable Autotrim by default on a new job stream. Autotrim is particularly important for Autosys configurations, where predictive analysis can see substantial impacts. In the case of other schedulers like Atomic, Autotrim features may actually be detrimental to the AI's analytics because they will remove items that should be there. The same principles apply to jobs scheduled less frequently. The target job executes on a daily basis and has a dependency set on a job that executes once a week. This is common with data management. Once a week, some consolidation process takes place and a report is generated. Again, that process has no bearing on the actual runtime values of our target job. Autotrim carves out the predecessor automatically. Here we have another small-scale model of a simple data process which runs for a few minutes. Calculations and the visual experience are distorted by a cyclical process that runs every minute. We decide to trim that predecessor. We should clarify that auto-trim options were manually disabled, which explains why the polling job was not trimmed by default. By adding the trim points, it's now in the lower window, which would also be true if auto-trim had been enabled. Entries are color-coded. A newly trimmed job is shown in green with a plus sign. Trim points added automatically with the auto-trim features are shown in gray with the letter A, and deleted trim jobs are in red with the minus sign. Let's try and add a new predecessor so as to explore those functions. AI provides a trim point finder. Potential candidates for trimming are identified and listed here. You can search for jobs with no frequency, varying frequencies, or by name. In the case of an Autosys integration, you'll also see File Watcher jobs and time windows. It's best to simply re-enable the Autotrim functions. Once this is done, we can click the Show Autotrim Changes, which will change the color of our job to gray with the letter A, confirming that the job is trimmed automatically.